Good evening, guys. We'll wait 2-3 minutes and then start for others to join. Hello, guys. Good evening. I hope you're all doing fine. Yeah. So, welcome back, everyone. Today's lecture will be continuing with straight lines. Do you remember what we did in the last lecture? Last lecture we did, I think we did, don't you remember? We were doing various forms of equations of line. Let me remind you. Last lecture we did I think a slope intercept form and 2 point form. So today we are going to do normal form and then we'll do parametric form. So with these two forms, these are the last forms of equation of straight line. We'll be completing the forms of equations of straight line. So after that, we'll continue with other topics. But for today, we are gonna do normal form and parametric form. So without further ado, let's get started. Let's see. Good evening, all. You can tell me if all the voice and videos and all is clear. Give me a thumbs up if it's all clear. Okay, super. Chalo, let's get started. Straight lines. So yeah, we will be gonna do normal form, right? Yeah, I think yeah everything is clear. So as you can see, it is also called perpendicular form. And theorem is basically I have given the name theorem, but it's not a theorem, it's just a equation. So what it says that the equation of line which is the distance of P from origin. That is the distance of line from origin is P. And that segment, the angle made by the perpendicular, which is also known as normal, with positive direction of x-axis. So if alpha is the angle made by that perpendicular in positive direction of x-axis, then the equation is x cos alpha plus y sin alpha equals to p. Let's see how this equation came. For that, let's move to the next slide. Yeah. So these are, let's say, the given information. As you can see, let me explain you what the given information is. Here, this is a line which equation we need to find. The OM is a perpendicular which is dropped from origin. So that means this distance will be equal to P and the angle made by OM with x-axis is alpha. So these all are given quantities. Now we have to find the equation of this line, which comes to be x cos alpha plus y sin alpha equals to P. So if you remember, uh, polar coordinates, if you remember, guys, see this triangle OMN is a right angle triangle, right? So we can easily write sine theta as, or in this case, it is sine alpha. 1 second, yeah. In this case, it is sine alpha. Sine alpha will be this distance is x and this distance is y because the coordinates are x comma y. So opposite upon hypotenuse. So y upon p. So I'll get y equals to p sine alpha. Similarly, cos alpha is x upon p. Remember adjacent or you say base upon hypotenuse. So from here I'll get x equals to p cos alpha. So I got the coordinates of m which are x comma y, which is p cos alpha comma p sine alpha. Correct, guys? Now, let me tell you one thing. What do we need to find equation of a line? We always use slope point form. So on this line, I got the point M, which comes out to be P cos alpha comma P sine alpha. Now, another thing I need is slope. So let me clear this out. So I guess we'll get a more clear diagram. So yeah, let me tell you this. That means we need inclination. What can we do, guys? See, this angle is alpha, right? This is a 90-degree angle. So this angle will be 90 minus alpha. this angle will be 90 minus alpha. And if this angle is 90 minus alpha, we know that this is perpendicular. So again, this angle will be alpha. Correct? Now, if this angle is alpha, this angle, and this is again 90 degree, so this will be 90 minus alpha. This angle will be 90 minus alpha. We want this angle. What it will be? 180 minus 90 minus alpha. That is 90 plus alpha. Is it clear till here, guys? Or we can do it in a much simpler way or other way. See, if this is not clear to you all, this is one way. I mean, this you should know because this is geometry, basic geometry. We will be going to use in many other sums. But still, what I'm trying to say is to get slope of the line L. Let this be line L. We get the slope of OM. What will be slope of OM, guys? Slope of OM will be y2 minus y1 p sine alpha minus 0 upon p cos alpha minus 0. Your p and p will get cancelled and I'll get tan alpha. Now we know that line L is perpendicular to OM. So that means if I want to find the slope of line L, it will be negative reciprocal. If you remember, let's reciprocal this, it will be 1 upon tan alpha and negative sign, which is minus cot alpha. So this is my slope and this is my point. If I use slope point form, I'll get the required equation. Correct? So it will be y minus y1 p sine alpha is equals to m. Cot alpha ko I can write cos alpha upon sine alpha into x minus x1 is p cos alpha. Let us cross multiply. So I'll get y sine alpha minus p sine square is equals to minus x cos alpha plus p cos square. Let's take x cos alpha on left hand side. So I'll get x cos alpha plus y sine alpha is equals to, here I'll get p cos square plus p sine square, which can be written as p into cos square plus sine square. And cos square plus sine square is 1. So which is equals to p. So if you can see this equation, which is x cos alpha plus y sin alpha equals to p. This is the derivation. Now, I purposely did this derivation because you need to know all the little things that we did in this derivation. Let's say we want to find coordinates of point M. So the procedure is important, how we find the coordinate of point M. Similarly, how we find the slope of line L and then how we applied the formula. So this is again a practice for you all to do at your home, that once again try to get the equation of line in normal. Do you guys understood this? Give me a thumbs up if it's all clear. Or if you have any doubt, you can ask. All good? Come on, guys. Ravi, I think it's first lecture for him, right? All good? Mamta, Anjana, all are regular attendees. If it's clear, give me a thumbs up. Or should I proceed? Hello? Come on, guys. Not clear? Okay, okay, super. Let's see the next question. Example. So, this example is basically for you all to understand how we can use the normal form. So let's get back to this. Alpha is this, P is 1. So we know that equation is x cos alpha plus y sin alpha is equals to P. That means x cos 7 pi by 4 plus y sin 7 pi by 4 is equals to 1. What is cos 7 pi by 4? Let me write it here. Cos 7 pi by 4. That means cos, I think 2 pi minus pi by 4, right? Which is equals to cos pi by 4. If you know allied angles, which is 1 by root 2. So if cos 7 pi by 4 is 1 by root 2, I think sin 7 pi by 4 will be same, which will be minus 1 by root 2. So if I substitute it here, I'll get x by root 2 minus y by root 2 is equals to 1. I can take LCM and I'll get x minus y is equals to root. This is my answer. I hope it is clear. It's a basic application of how to use the normal form. All good till here? Let's see the next question. Yeah. Now this is an important question because for your NCRT exams, for your boards exam, I think 11th boards exam, theory exam. So here, please remember what is the normal form. There are fixed steps to get normal form is x cos alpha plus y sin alpha equals to P. Now, P is perpendicular distance from origin. So that means that P can never be negative. So let's say first step is to take the constant term on the one side so that it is not negative. Now, if I take minus 1 on the other side, it will become, sorry, if I take plus 1 on the other side, it will become minus 1. Now, minus 1 is a negative quantity, but we want positive. Why? Because x cos alpha plus y sin alpha is equals to P. Here P is distance. So P should always be positive. So I have to write this equation as minus x minus y is equals to 1. I hope it is clear. This is the first step. Take the constant term on one side such that the equation or the constant term is positive. Clear? Now the next step is the equation will be of the form ax plus by equals to c. What we have to do is divide by under root of a square plus b square. So here, what is under root of a square plus b square? It is under root of minus 1 square plus minus 1 square. A की जगह पे minus 1, b की जगह पे भी minus, which is equals to root 2. So if I divide by root 2, I'll get minus 1 by root 2 x minus 1 by root 2 y is equals to 1 by root 2. Correct? Now, the next thing we should do is x के साथ क्या था guys? It was cos alpha. What was it? Y? It was sin alpha. So that means cos alpha is x cos alpha minus 1 by root 2 and sin alpha is also minus 1 by root 2. Correct? So this means cos alpha is negative, sin alpha is negative. If you remember trigonometry, sin alpha is negative in third and fourth quadrant. Cos alpha is negative in second and third quadrant. So that means my alpha should be in the third quadrant. Now, which angle in the third quadrant gives minus 1 by root 2 for cos? So it is very simple. It is pi plus pi by 4. See, this is pi, right? If we move into the fourth quadrant, it will be pi plus pi by 4, which is 5 pi by 4. So that means my normal form will become x cos alpha. So we got alpha as 5 pi by 4. Cos 5 pi by 4 plus y sin 5 pi by 4 is equals to 1 by root 2. This is my normal form. I hope it is clear. This is very important for theory examinations. If it's clear, give me a thumbs up. If you want to look at it, let's look at it. You can look at it. What I did, a bit of trigonometry is involved here, guys. So I hope it is clear. Okay, super. Thank you all very much. Chalo. Now these are some basic formulae which we need to remember. The perpendicular distance formula and distance between two lines. Now I introduced it here because we'll be needing it in next topic. That's why I introduced it here in the middle while studying equation of line. So let's see. We'll be discussing in these formulas again after we complete it. But this is just the basic. I hope you all know what to do this. If I want to find, this is a line and this is a point P. If I want to find this distance D, so this distance can be given by mod of ax1, that means substitute point in line. So ax1 plus by1 plus c upon under root of a square plus b square. Similarly, if there are two parallel lines, now let me tell you, if the lines are parallel, that means their slopes will be equal. So if there are two parallel lines and I want to find the distance between them, obviously here distance means the perpendicular distance, right? If in a sum it is given only distance, then we by default mean perpendicular distance. No need to mention separately that they are talking about perpendicular distance. So if I want to find this distance D, and the equations of lines are ax plus by plus c1, ax plus by plus c2. Now I told you that the lines are parallel. That's why here a and b, and here also same a and b. There is no difference in a and b. There is only difference in the constant term, which is c1 and c2. I think we discussed this in the last lecture. Since the slopes are equal, a and b will be the same here and same here. So what is the distance given by? It is mod of C1 minus C2, that is difference of constant term. Now, please remember, to get difference of constant term C1 minus C2, the constant terms must be on the same side. Here, C2 is on the LHS. Here, C1 is on the LHS. This is what I'm talking about. If here C2 would be on RHS and C1 would be on LHS, then we cannot use this formula, or if we use this formula, my answer will be wrong. So make sure that in both the equations, the constant terms are on the same side, either on the left hand side or on the right hand side. Now, the purpose of using modulus is very simple, that we are finding distance and distance is always positive. That means we need to use modulus, or else it can be negative also. All clear till here? This is a basic idea. Now let's see some example to just make sure that we know how to use a formula correctly. So here distance will be, first we have modulus. What we do is we substitute the point in the equation. So I'll get 3 into 3 minus 4 into 4 plus 10 upon under root of coefficients का square. हुआ coefficients 3 square plus minus 4 square. Simple, done. So I got 9 minus 16 plus 10. I think this is root 25. So 3 by 5. We don't need mod now because it is positive units. Correct? I hope I have not made calculation error. Yes. Nine minus 16 is minus. Yeah. Right, right. Next. Here is an important example between two parallel lines. Now, I said key, if the lines are parallel, A and B should be same. So that means, let's say suppose this AX plus BY plus C1 equals to 0. Then I cannot write it as AX plus BY plus C2 equals to 0. Why? Because here A is 5, B is 3. Sorry, B is minus 3. Here A is 10, B is minus 6. So for them to be equal, we need to divide this line by 2. So if I divide this line by 2, I'll get 5x minus 3y minus 9 by 2 equals to 0. Now I can compare it with ax plus by plus c2 equals to 0. Now as you can see from here, what is the value of a in both? 5, obviously it has to be same. B is minus 3. Let's see what is C1. C1 is minus 4 and C2 is minus 9 by 2. So if I use the perpendicular distance between parallel lines, it will be mod of C1 minus C2. It will become plus, right? Upon under root of a square plus b square. I think ऊपर आएगा 1 by 2 upon 25 plus 9 under root of 34. It is already positive, right? So no need of mod. So 1 upon 2 root 34. I hope it is clear. So before using distance between parallel lines, make sure that your A and B both are same in both the lines, because the lines are parallel, and if the lines are parallel, slopes are equal, and if slopes are equal, that means A and B should be same. Is it clear, guys? Give me a thumbs up so we can move in the next. Okay, superb. Thank you, Anjana. Now, let's see what we are. Oh, everybody. Yeah, very good. Kid. So now the last form of equation of line, which is the parametric form, or also known as symmetric form. So we took a bit of a detour of perpendicular distance and the distance between parallel, but yeah, it's fine. So what is symmetric form and parametric? Here you can see. Sorry, yeah. This is the symmetric form of line. Now, symmetric form or parametric form means in terms of parameter. Here we have the parameter theta. So the equation of or symmetric form of line looks like x minus x1 upon cos theta equals to y minus y1 upon sin theta, where theta is basically inclination. Yeah, we have here theta is inclination. So if theta is inclination, it should belong between 0 to pi. Here we cannot include pi by 2 because we have cos theta in denominator, and if cos theta in denominator it is, then cos pi by 2 will be 0. So here we cannot have 0 in denominator, that's why we have excluded pi by 2. Now the derivation of this is very simple. Again, it will come from slope point form. What is slope point form? Y minus y1 equals to m tan theta into x minus x1. I can write tan theta as sin theta upon cos theta into x minus x1, y minus y1. Now bring sin theta here. So y minus y1 upon sin theta is equals to x minus x1 upon cos theta. I got the equation. Where theta is inclination. This is the symmetric form. Let's see, the more important is the parametric. Yeah. So, here, if you read it, let me tell you, this, I'll explain you. This is a line L, whose inclination is theta, correct? And point A is given as x1 comma y1, correct? So by parametric form, by symmetric form, we know that x minus x1 upon cos theta is equals to y minus y1 upon sin theta. If I write this equals to r, where r is the distance of A to P. That means A point, which is x1 comma y1, and P point, which is x comma y. So basically here r is distance between these 2 points. Here we have taken mod r because again distance should always be positive. So from here, if I equate these two and these two, I'll get x equals to x1 plus r cos theta and y equals to y1 plus r sin theta. Now let me remind you, X and Y were the coordinates of point P. That means now I can write the point P in terms of R and theta, which is x1 plus R cos theta and y1 plus R sin theta. This is nothing but if you remember the what do you say change of origin or shift of origin. This looks similar to that. Coordinate equals to old coordinates plus h. So it is similar to like that. I will not go into the details, but just remember Hello. Yeah, guys, my voice clear? Okay. Sorry, there was network Wi-Fi issue. So yeah, we are back. I think we were here. I was telling. Yeah, we are fine. Okay. So I was telling ki here, P is any random point on this line. That is x comma. It can be here, 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 anywhere. And if I know the inclination of the line theta and the fixed point A, so if I know fixed point A and inclination of the line theta, that means I can get any random point which is at a distance r from fixed point A. Let me repeat once again. Please listen very carefully. If I want to find any random point on this line and I know the inclination of that line and the distance of that point from the fixed point A, then I can get that point. So this is basically the parametric form of equation of line. So let's see how questions come. And before that, this is what we discussed. The same thing I told you all that just yeah, the same thing I told you all this. Sorry. Yeah. R is a distance of point, any point on the line, which is a distance of x1 comma y1. And second, theta is the inclination. So let's see how the question comes. So here, first let us see how to use the formula. So find the equation of straight line in symmetric form. Given slope is 3 and passing through the point this. That means this is a fixed point A, which is basically x1 comma y1. And this is a slope, that is basically this is tan theta. So if tan theta is root 3, that means theta is pi by 3, 60 degree. So what will be the symmetric form? X minus x1 upon cos theta is equals to y minus y1 upon sin theta. So this will be x minus 2 upon cos 60 is half is equals to y minus 3 upon root 3 by 2. This is my answer. Symmetric form, right? This is a symmetric form. Obviously, symmetric form is just the name, but our main helpful thing is the parametric form. Many of the books or many of them believe that both are same. Yes, both are same. Just we introduce the constant which is r. And in our case, r is a distance between any random point and point A. Now, we are done with two forms, that is normal form and uh, parametric form or symmetric form. We are over with the different forms of equation of line. In between, we also took the concept which are perpendicular distance and distance between two lines. So here are the questions based on today's theory, which is if the perpendicular distance of straight line from origin. So let me draw a diagram, it will be better. This is a straight line, x upon a plus y upon b equals to 1. If I want to use the perpendicular distance formula, I'll have to write minus 1 equals to 0. Here is the point P, which is origin only, and this distance, let me write it O, is given as P, and we have to prove this. So, perpendicular distance equals to mod of, substitute this point here, so I'll get 0 plus 0 minus 1 upon under root of coefficient. What is coefficient of x? 1 by a, coefficient of y 1 by b. So if I cross multiply, I'll get under root of 1 by a square plus 1 by b square equals to mod of minus 1 is 1 by p. If I square on both the sides, I'll get 1 upon a square plus 1 upon b square equals to 1 upon p square. Simple, we got this. Correct. So these are questions which obviously comes in your board exam or theory paper, you can say. So let's see the next question. Yeah, this is a good question. I'll give you 1 minute to read and grasp what the question is trying to say. Right? Let's see. I'll move aside. Come on, guys. Let's see. Let me read the question now. I hope you have done it. A straight line whose inclination with positive direction of x inclination is pi by 3, then I know the slope is tan pi by 3, which is root 3. Again, let me tell you, this is where we will be using the slope intercept form. So here, the equation of line will be y is equals to mx plus c. Now, to get the equation of line, we need to get c. How many unknowns? 1. How many conditions? 1. Distance. Yeah. Is my voice and all clear, guys? Give me a thumbs up. Hello. Okay. Yeah. All good, guys. My voice, video, audio, all is clear. Give me a thumbs up if it's all clear. Video is not clear. Why? Just a second. One. I'll do. Yeah. Let's see. Now I think it is clear. Yeah. Chal. So this was the question here. Now the distance of 4 units from origin. So this is the given line. Yeah. And this is origin. So this distance is given as 4. What is the equation? Let me write equation root 3x minus y plus c equals to 0. Remember, we need c. So that means if I use perpendicular distance formula, I'll get 4 is equals to mod of 0 minus 0 plus c upon under root of coefficients ka square. So I'll get 3 plus 1, right? So that means 4, 3 plus 1 is 4 and under root of 4 is 2. So 4 into 2 is equals to c. Modulus of c. That means modulus of c equals to 4 2s are 8. C equals to plus minus 8. We'll write c equals to 8. Why? Because positive intercept on the y-axis. If as we know that in y equals to mx plus c is the y intercept, and it says that the y intercept is positive. That means c should be positive. That means c is 8. Very simple. So I got my equation y equals to root 3x plus 8. Simple. Correct? That's how we rejected the negative. So I hope it is clear. This is a good question. Let's see what we have next. Sorry. Yeah. So here, if P and Q are perpendiculars from origin to the line, then show that. So same thing. These are the equation of line, and here is origin. So I am writing directly. I hope you will understand. If you do not understand, just raise your hand or write in the chat box. So P will be equals to modulus of origin. So substitute origin here. So I'll get 0 plus 0 minus a. This a will come on the left hand side upon under root of coefficient. What is coefficient of x? Sec square alpha plus cosec square alpha. That means P is equals to a upon under root of, I can write sec square alpha as 1 upon cos square plus 1 upon sine square, which I can write it as a upon, if I take LCM, I'll get sine square plus cos square upon sine square cos square. Therefore, P will be equals to a upon sine square plus cos square is 1, right? So I'll get 1 upon sine cos. So P is basically a sine alpha cos alpha. Correct? Let me multiply and divide by 2, because 2 sine alpha cos alpha is sine 2 alpha, and I cross multiply this, so I'll get 2p. Let this be equation number 1. Now, if I want to find equation number 2, that means Q is equals to, now we have this equation. So I'll get same 0, substitute origin, minus 0 minus a cos 2 alpha upon under root of coefficient, which is cos square alpha plus sine square alpha. So this is the 1. So I'll get Q is equals to a cos 2 alpha, equation number 2. Now we want 4p square plus q square. So square and add 1 and 2. So if I square 1, LHS I'll get 4p square. If I square this, LHS I'll get q square is equals to RHS a square sine square 2 alpha here plus a square cos square 2 alpha. If I take a square common, I'll get sine square plus cos square, which is 1. So that means I got 4p square minus q square is equals to a square. Correct, guys? Look at the question. Sometime if you don't understand, please ask, or else give me a thumbs up if it's all clear. All good? Chalo, let's see who all got the question. Give me a thumbs up, guys, if it's clear. Come on. You need to look at the question again. Mahesh, Mamta, all clear? Anjana, super. Chalo. Let's look at the last question for today and we'll pack up. So it is a very big question, but very simple. Just look at the question. Line L has intercepts A and B on coordinate axis. Now, remember in the last lecture I told you, whenever question has the mention of both the intercepts, A is the x intercept, B is the y intercept. Then we write the equation of line as in double intercept form. X upon A plus Y upon B equals to 1. That means X upon A plus Y upon B minus 1 equals to 0. Right? When the axes are rotated through a given angle, keeping the origin fixed, the same line L has intercept P and Q on the transformed axis. So next, again, the same equation will be capital X upon P. Why I'm using capital X, guys? Because we have rotated the axis. That means X and Y will definitely change. And the intercepts became P and Q plus capital Y upon Q is equals to 1. Or I can add minus 1. Sorry. Yeah. Minus 1 equals to 0. Now, let me tell you one thing. Let me draw a diagram here. I'll rub it out. So this is suppose, sorry. Let's say this is the equation of line. Now, if I rotate the axis, let me draw with a new color. If I rotate the axis like this, so these are my new axis, capital X, capital Y. These were my old axis, small x, small y. Please remember the distance from origin, this distance will remain same whether how many times we rotate the axis. So the line remains the same. The distance from origin also remains the same. Correct, guys? This distance will always remain the same because it is distance from origin. No matter what we have x-axis, y-axis or not. This distance from origin will always remain origin. Whether we have anywhere, the axis can be anywhere. Correct? So let me rub this diagram. So basically we have to find origin is 0, 0. So let's say distance from origin for line 1 will be equals to distance from origin from line 2. I have my D1 equals to D2. So let's say D1 is distance of origin from 1. Let us use perpendicular distance formula. What is the formula? 0, 0 minus 1 upon under root of coefficient ka square is equals to, here again we have to substitute origin in this line. 0, 0 minus 1 upon under root of 1 upon p square plus 1 upon q square. Correct? So here I'll get 1 upon under root of 1 upon a square plus 1 upon b square is equals to 1 upon under root of 1 upon p square plus 1 upon q square. Now if I let us cross multiply. If I cross multiply, I'll get under root of 1 upon p square plus 1 upon q square is equals to under root of 1 upon a square plus 1 upon b square. Now those of you guys know we are very close to the answer. That is just need to square on both the sides. So I'll get 1 upon p square plus 1 upon q square is equals to 1 upon a square plus 1 upon b square. This is my answer. I hope it is clear. This is also we need to. So yeah, if you have any doubts, please ask or we'll end the session. Come on, all good till here, guys? Give me a thumbs up. I know. Superb. Anjana and Mamta. Raghu. Yeah. So let's end the session for today. Now remaining part, I think some part is remaining. The reflection of point in a line or foot of perpendicular, that 2, 3 parts are remaining. We'll do it in the next session, which is tomorrow. So meet you guys tomorrow. I hope you understood the lecture. Till then, bye bye everyone. Take care.